Hello everybody. In this video we will discuss reaction of aldehyde or ketone with a secondary amines. So if you haven't watched the video of aldehyde and ketone which reacts with a primary amine to make amine, so you should watch that video first before you watch this video. So in this case, when a secondary amine reacts with a carbonyl group, it makes enamine. So we will go over the mechanisms and reaction fully in detail. So let's briefly start. What is a secondary amine? So a amine is called secondary amine when nitrogen is connected to two carbon chains. So you notice that is a carbon chain here and that is a carbon chain here. So that's a secondary amine. So this is a secondary amines. Secondary amines. And when we have that reactions, we're gonna form enamine. So here is another details that you need to keep in mind. The catalyst. So the catalyst, although it is acidic, but you don't want too much acidic proton. So the pH has to be perfect for this reactions to be optimized. If the pH is too low, so at low pH, when the pH is too low, what would happen? The nitrogens on the amine would get protonated. So at low pH, you see your nitrogens will be protonated. So this is true for amine formation as well. So when you have lone pair nitrogens and H plus, so this will form NHCH3 HCH3. So this would be positive charge. So this one can't make a nucleophilic attack. So this one doesn't have lone pair. I'm having too much typo today. Doesn't have lone pair to attack the carbonyl carbon. So the best pH is to be 4.5. So I'll show you why you cannot also have high pH. What would happen when you have high pH? Okay, so I'm gonna delete this one and then we'll go over with the mechanisms. Okay, so let's go over with the mechanism. So what is the first thing that would happen? The first thing that would happen is the lone pair on nitrogen will attack the carbonyl carbon. And why would that happen? We know that carbon is delta positive. Carbon is electrophilic. If something is electrophilic, it would love electrons, so it will attract it towards the nitrogen, and this is what would happen. So simultaneously, your pi electron between C and O will move up to oxygens because you cannot have octet. So I'm just going to ignore all the equilibrium signs for this mechanism, and we'll just move forward with this reaction. So we got CH3CO minus CH3, and then I'm going to color code. So we got NH CH3 CH3, and nitrogen has 4 bonds. So based on our shortcuts, every time nitrogen has 4 bonds, it should have a positive charge. 2 bond negative, 3 bond neutral. So now we have a positive charge. So this is where the slightly acidic proton will come into play. So when you have O negative ion, it will immediately get neutralized by whatever proton available. So we have some acidic proton that's present. Again, it's not a lot of proton, but some protons, just enough to protonate this. So we got our CH3, COH, CH3, and then we got our, okay, let me color code perfectly, and CH3, CH3. And every time you see a positive charge, let's neutralize the positive charge. So the base that we just released from here, so whatever can abstract a proton, that's your B. So you'll immediately abstract the proton to get neutralized. And as a result, you're going to be making CS3, COH. And we know that oxygen has two lone pairs, CH3 and NCH3. Okay. So now we have regenerated our HB plus as well. So we have slight amount of protons. So we regenerate this one. So this is where slightly acidic conditions comes into play. So when you have slightly acidic conditions and some of these lone pairs will get protonated. Again, it could be nitrogen, but if it does, that's basically going backwards. So you'll find out most of these reactions are in equilibrium. Some equilibriums are more biased towards left, some are more biased towards right. Okay. Okay, so let's say we protonate this water. So what would happen? So when we protonate this water, protonate this oxygen, CS3O, H, H, H. So oxygen has 3 bonds based on our shortcuts. When oxygen have 3 bonds, it will be a positive charge, CH3, and we got ourselves NCH3, CH3. Okay, so at this point, our next goal should be to neutralize the positive charge on oxygens. So let's do that. We can do that by removing this bond here. So by breaking this particular bond, so if you break it, you neutralize. So oxygen would pull the 2 electron between C and O, and it will go away as water. So if this thing goes away as water, so you noticed the carbon does not have octet anymore. So how can we bring back the octet? Well, we can bring back the octet by nitrogen, with the help of nitrogen. So nitrogen will say, here you go, carbon, take 2 electron from me and be satisfied as an octet. Okay, so I will bring this one here. So let's recap. Let's recap here. So we will neutralize the positive charge on oxygens by bringing these 2 electrons, the bonded electron, back to oxygens. Simultaneously, nitrogen will support the carbon's octet by providing this lone pair. So now as a result, you will see your molecules like this: CH3, C, double bond, CH3, and we got our N, CH3, CH3. Okay, so nitrogen has 4 bonds, so it should be positive charge. So this is, and carbon also has octet. See, carbon has 4 bonds. Okay, so this is where things differ. If you had primary amine, so this was a secondary amine. If you had primary amine, so I'm going to draw what would have happened if you had primary amines. So CH3, C, CH3, double bond N, CH3, H. So this is, you would have gotten if you had primary amine. So if you had primary amine, this is what you would have gotten. Okay, so now this thing, oh no, this looks ugly. So if you notice, what's the last step of this mechanisms before? All we did was we had a base that abstracted the proton to neutralize the nitrogens, and as a result, we got our amine. So we got our amine. CS3, C, CH3, N, CH3. So this is an amine. Okay. So this is what we would have had if we had primary amine. But there is no proton here to be abstracted, right? So how can we do this? So this is where things will slightly differ from primary amine versus secondary amine. So what would happen is one of these carbon chains, okay, one of these carbon chains since both sides are equal, so it doesn't matter. So your base would abstract one of, okay, I will do this one. So your base would abstract one of these hydrogens, so which means those two electron would move to here, and these two electron would move to nitrogens. And then, oh no, we're out of space, so let me move this one out of the way. So then what we would get is enamine. So it would look something like this: H, H, double bond C, C, H, 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 and N, CH3, and CH3. So you notice this carbon atom has octet, nitrogen has 3 bonds, and also it's neutral. So this is called enamine because enamine. So you notice it says C double bond C, so that stands for alkene, ene. And then we also got amine, so that's our enamine. If we had primary amines, here we would have gotten an imine. So that's the difference between amine and enamine. So let's look at one problems and shortcuts. Shortcuts or tips. So let's say we have something like this. And CH3, CH3, H. So first thing that you want to look at is if you have tertiary amine, it won't react. So first thing that you want to look is what kind of amine is this one? Step number 1, what kind of amine is this one? Well, this is a secondary amine. So from there, I know that my product won't be an imine. Again, trace acid, trace amount of acid. So let's look at here. So it won't, so when you have secondary amines, so try to look for hydrogens on the neighbor carbonyl group right here, neighbor carbonyl group. You could have done the other way too. I'm just doing this one. And try to get rid of water. So this is H, O, and H. So that's minus water, just like we did for imine. But this time you need extra hydrogen from neighbor. And then organize the electron. Hydrogen, so proton is going away, which means these two electrons would move back here. And one of the pi electron would end up making a bond with nitrogens. Again, this is not a mechanism. This is just shortcut tips. So minus water, these two electron after proton leaving out, bring back here. And there will be oxygen is gone. One of the pi electron can be utilized to make the N bond. So the product that I would reconsider is this is how I would draw the product. Okay, put them side by side. And CH3, CH3. Okay, so delete the oxygens, connect them here. So let's start here. So you're gonna have a double bond because hydrogens went away. The oxygen is also gone. Now it's connected to nitrogens. And that's how you're gonna draw the shortcuts, shortcut or tips, how you can draw the product. So first thing that you wanna figure out is if it is primary or secondary amines. All right, let's stop this video here.